Okay. So we are all set. Yeah, I got two different keyboards. One is English, the other is Turkish. So this nagging thing that I keep moving, that's just my keyboard instructions, and just keeps floating on my screen. So just have to ignore it. It's nothing to do with the class. All right. Now, I think we left at getting acquainted with the type of qualitative data. We talked about ordinal, nominal. Um, yeah, this is the last slide I did, which was 288. Okay. So continuing with the data types, I will now talk about the quantitative data, or how you are going to differentiate between the type of data that works in the quantitative analysis. And there is something called the interval data. That's one type, which means that when your set of identifiable numbers for good, Michelle just walked in, so Michelle is getting connected now. So like it says over here, the interval data means that there should be several numbers that can be grouped together to come up with a conclusion of an event being successful, unsuccessful, good or bad, or any decisions that you can make based on the interval data is not it's not dependent on just one outcome of a number, but it could be several numbers together that based on the nature of the observation or nature of your analytics uh, can only come up with a decision or come up with a conclusion that is a collection of numbers. Like for example, in Olympics, like we do scoring in, I think it's in tennis, you have sets, you have, how many sets one of the players has won against the other. So those sets basically together are going to give a result, or will be responsible for the outcome decision on who is the winner or the loser. So one type of score in situations where a number of scores collectively represents the rationale um, or the outcome of one event against another collectively is going to require interval data. I think we've got Brooks. Okay, hi Brooks. We are talking about interval data, and this has to do with the quantitative data types. Similarly, sorry, sorry. So this is what interval data is. So let's suppose the score is 6.0. Even in swimming, I guess those kind of events, just one dive itself is not conclusive of someone's performance, and it requires number of performances to be put together to add those numbers or numbers of individual dives to come up with the judgment of whether uh, one of the contestants has won or lost, or with the and then there are several examples to it. So interval data, you understand that it's a collection of numbers of events that are multiple instances put together to collectively represent the outcome of something. Then we've got the other one, which is a ratio data. Ratio is very simple. We all deal with it off and on. It's just the number of times one number is greater or less than the other one. Like scoring 40 points has twice the value of scoring. No, sorry, scoring 40 points, yeah, has twice the value of scoring 20 points. So the ratio between the two would be 1:2, because 20 points is what is the difference between the number 40 and the number 20. So 1:2 is the ratio. You simply put, how you measure it with the ratio of putting it as 40, and you use a colon sign 20. And to simplify it, this would be divided by, if we divide it by 2, it'll be 2:1. Okay. So that's the ratio thing. Nothing complicated about it. So this is also one type of number. If you're going to ask the application of the software you're using to do ratio analysis, or do multiple ratio analysis, or do ratio analysis of interval data, that can also be different ratios in a set. So these numbers can be played with in so many different ways. It's not easy for me to explain it unless I have something that is actually doing the job, or representative of quantitative analysis. So those softwares is not part of the course. I'm not running it, but I'm just letting you know that these are some of the ways in which quantitative data is computed, or is basically analyzed in quantitative analysis. Then we've got statistical analysis also in quantitative data, which we will also touch upon. Mixed method approach means that mixed method, basically the slide is at the wrong place. But remember at the very top, when we were talking about the type of data analysis, I think we also looked at what is called mixed method, which has to do with quantitative and qualitative analysis. It could be a mix of analytics. So that is called mixed method approach. And you need to make a data management plan for that. Data management plan is not part of the course, but it is mentioned just for your information. Data management plan is a, like it says, is a written document which allows you to not only just design the collection of data, but how do you plan to use it, and how do you plan to, do your analysis, and things of that nature. But you have to plan it in a certain way, and that plan is complicated enough that it's not worth talking about right now. But those who do data analytics, or those who are data scientists, they definitely know how to create one of these data management plans. Okay, so interval data, ratio data, that's just to give you an idea that there could be different type of quantitative data sets that is dependent on the um, nature of the surveys, and how do you uh, instruct your application software, or anything that you're utilizing as a tool to do your analysis, to distinguish between the type of calculations, or to say that what matters a lot in data analytics is how you feed that data, or your collection of data is based on numbers that have a certain quality, or certain value, or certain distinction in coming up with the combination of it to allow for the methods of analytics to work upon it. So there could be 5 sets of data in case of interval data, where you can split it into different group. Each group would have, several ratios, or several different interval data. So all of that is what you will have to compute and put together. And then there would be data sampling techniques also, that has a lot to do with numbers. And there would be statistical analysis, that also would be analytics, not the data types, but the analytics portion. So we will catch on that as well. Right now, we are moving from the type of quantitative data as an intro to data collection methods. The type of methods that I have put in these slides are basically traditionally or standardized methods, and it is got a certain characteristics of its own, And therefore, we need to also visualize the same types of data collection methods, all of these, uh, with how this would work online or in the internet environment or virtually. How do we conduct these? So observation techniques, these are one of the ways in which you collect the data, and we are only talking about qualitative right now. It's you know just one of those things which may have both qualitative and quantitative data, but observations typically will involve the qualitative data types. Um, and therefore, I would say that observation techniques, which I will explain as well, think of it as majority of the information you're going to collect through this method will be qualitative data. Like observations are something that you have a way of figuring out or coming up with some sort of collection of data or information that in your opinion or based on your best observations may be contested or may be interpreted differently by someone else who is in the same place and doing the observation. So, unless it is something very obvious and nothing very subtle, or if it is something that can easily be quantified, uh, you would have different observations written or captured if it is done by more than one individual, because it has got different elements that work together, like your preconceived notions, your biases, your perception, your way of doing critical thinking. So soft skills come into play when you are a researcher doing observations. Observations is usually applied in social settings or in environments that you know like in grounded theory, for instance, where you are on the ground and you are immersed in a situation or in a kind of a setup that requires for you to spend time, and over time you do your own observation and collect information, and your research sort of moves in the direction that it would take you from where you started to where you want to move or maneuver, because circumstances, when you observe them closely, the situation gives you more ideas and gives you more ways of doing research in directions which initially you thought that you would take, but it has now moved your research in another direction. So that is a way of how grounded theory works. And grounded theory usually means, as I said, you're immersed in an environment, and over a period of time, your observation deepens and you find more ways and more you're given more directions or better directions when you're doing your observations in that situation. So observation techniques is one. Social experiments, by the way, could be another one, where you are documenting something or you have captured an event which you, I would say that you may have looked at it in YouTube, where social experiments are for the viewers to come up with the conclusion by looking at the behavior of certain things or certain events, which is another way of doing observations. And we call it social experiments. Then we've got surveys and polls. Surveys and polls are two different concepts in the sense that even though both collect the information, but surveys generally are more elaborate, more detailed, and they're crafted through careful, um, um, careful preparation of carefully preparing the questionnaires. And there is so many techniques attached to it in building surveys that you need a level of expertise to understand and to know how you're going to address certain issues, like in the way you're going to write your questionnaire. So there could be some issues that are very sensitive. You don't want to be too open about it. Yet, in a way, it does allow for you to collect certain type of or certain level of information that is an indication for you to make to have a sense of knowing where it might take you. So it would be very difficult sometimes to create those questionnaires as opposed to the ones that are simpler and it is on general topics and not as complicated, but structuring it in a way that it covers the entire subject or the type of information is such that you need to slowly build that momentum for the survey participants to respond to without hesitation. So you use a language, and then there could be open-ended questions and close-ended questions. So there are different flavors to the type of questions according to the nature of the nature of the or the objective of your survey. So if it is open-ended questions, it means that you're not giving a lot of choices as if you are sort of hand-holding and giving them options to select from, but rather leaving it for the subject to write about it the way they want it. So you're not the influencer really there. It's a freehand information that can be more on the descriptive side. And then there could be close-ended surveys, which means that you do give choices and you do have some parameters or arrangements of how you're going to set those questions. So the participant can simply tick it off, tick him, and that way you can do the collection. Surveys can also collect quantitative data as well as qualitative data. So depending on the structure, the nature of the issue that is for research purposes, as well as the objective of your surveys, you will design your questionnaires. And that is surveys. Polls are very simple questions. You don't need a lot of time, or the whoever is taking it off as a choice are given very few options. Yes or no, good or bad. So these are binaries, could be numbers, or it could be, something that is translated as yes, no, good, bad, and things of that sort. But polls are easy to get, and polls usually don't require a lot of effort for the participants or anyone who is and it is not really focused on certain um, it doesn't deal with very complex issues. It is very simple to pose as questions. So polls and surveys are different, and they should be differentiated according to the um, the attributes of surveys versus polls. And why I say that is because it would be part of your exam, and if I have to look it up somewhere in the slides, I can tell you that that is actually shown in one of these slides. You could see that this is saying differentiation between surveys and polls. So you on the left hand side in this column, you can see what surveys are about versus what polls are about. In the exam, the pet question, or usually the question that I see, is that they just give you these attributes and ask you to fill in the top heading, which would make it either either the characteristics of a survey or the characteristics of polls. So that's typically what comes. Um, so surveys and polls is another type of data collection method. Then we've got interviews. Interviews usually are one-to-one, and they involve issues and subjects that that are of interest to the researcher based on um, collecting not only just the answers to questions, but also uh, looking at the the I guess the expressions, the physical observations of the individual, if they're restless or they're easy about answering a question, or if it is something, usually the subjects in the interviews generally are specialists or people who are able to deliver um, answers to questions on some type of niche, um, um, type of I guess subjects, could be something that would also, for which you have to prepare yourself enough that you are able to interact with whoever you're interviewing. So interview is more intimate, more intense, and requires expertise level for both parties. And also for certain type of information which otherwise you wouldn't get in surveys, and you wait for the cues to allow for you to ask more leading questions, because there are different types of questions also. So one of them could be leading questions, or questions that take change directions from the script that you have written to another direction on account of the nature of the subject. Then interviews are more feasible. um, Focus groups are the type of people or the group of people that have some that requires two sets of staging, or two different ways in which you can stage for focus group. One could be for the group of people that have homogeneity or have similarities on the subject matters that you can discuss, so that you can come up with something new, or a new knowledge can be built, or more information can be collected, so that you would be in a position to gather something, or at the end of a focus group interview you gather something new. Then the other type could be non-homogeneous, or those groups that oppose each other. Somehow their views are different, so in certain situations you want, um, in focus groups you want to set up a group that would actually bring up subject matter that kind of allows you to bring to the surface new issues or new arguments which you weren't aware of. So interviews and focus group both take different directions, and they are not as specific to what the outcome would be eventually, but you come up with the after end of the interviews and focus group, you always find and discover something new, or the new issues emerge out of it. So depending on the type of research, you have to decide if the if surveys and polls is the right technique for gathering certain type of info, or observation techniques are better, or it's best to do interviews and focus group. Will depend on how you're going to create your data management plan, and how you're going to design the procurement of information. The document studies, of course, is got anything and everything to do with digging into journals, specific type of newspapers, or whatever the source might be. It is documented information, even books, even collection of any kind of research papers. All of those are document studies, so straightforward. Case studies, of course, means simulating a situation or relying on a situation that historically is documented, which gives a set of events that and gives a conclusion to, or gives a solution as well. So those could be case studies, and it depends on whether those case studies have to do with the subject matter or events, or any sort of outcomes from historical data, to how those problems got resolved. And purely talking about research, case studies in technology is different, in sociology is different. But here I'm just generally talking about when you have to do data collection. So those case studies will guide you through what type of information, or where certain information resides and how it was collected. So you can basically create a new study for something that eventually you can build on top of for research purposes. Then we've got the sampling techniques, because in the reality of how the data is collected, Generally, we are dealing with all sorts of data tables or data types, or you could say that certain data types are so large and so difficult to come up with the come up with the numbers that you can utilize, or you cannot capture the entire data sets only because they're too large of a information, and therefore to for you to be able to find or to do some tests that you can rely on, and the tests that you would conduct based on the sample, which otherwise would be representative of the whole population. You need to have certain type of techniques put in place that are recognized industry wide. So you are not creating something randomly, or you're not picking sample random or at your own pleasure, but rather in conformity to the ways in which the samples are taken from the population. Population means the entire data or the entire group that covers everything and anything on which the research is being done. But because we're going to talk about sampling techniques now, I would point out two types of samplings. One we call probability sampling, the other one is non-probability. Probability simply means the uh, the likelihood of something happening or not happening, or the probability that is not controlled by humans or the machine, but basically it is something which has a method to it, or it has a method that is allowing you to pick something that is non-biased, and it is not something for which you had to make a proactive choices to collect that sample. And because it is probabilistic or probability involved, nobody is going to say that, you have made your own choices randomly, but rather with the application of a probability of something happening or not happening that is mathematically inclined and gives equal chance of one event to be presented or not presented. That's why we are going to call it probability sampling and non-biased sampling. Second is a non-probability, which means that certain samples are difficult to get, or uh, to get those samplings will not be representative of the type of situation, or maybe that sampling is very difficult to get to, and therefore you have to proactively go and look for it. And a lot of times in non-probability sampling, we deal with something called recruitment, or we call, and it's not a recruitment as in human resource recruitment, but it's called sample recruitment. And it is a subject in itself where you have companies or specialists that actually provide those samples, mainly if it has to do with human subject. So to find certain type of participants that has to be recruited for uh, creating non-probability sampling, you have to find the homogeneity or typical traits or something for a very peculiar, as in in clinical sciences, you have to find people who have a kind of disease which may be very rare, and you cannot advertise easily. You'll have to hire recruiters for the type of typical clinical subjects that needs to be found, and for which also there is a lot of legalities that you have to fulfill. So it is kind of a specialization. And when we are talking about non-probability sampling, we are, looking at open grounds for anyone to participate by you or by the researchers to proactively identify with or invite or look for those people. And therefore, since it is done through contacts or through specialists, it is it is something that is looked at very carefully by by whoever you are doing research for instance. So there is a protocol, there is rules and methods that you have to follow in collecting samples for non-probability. More for being right now we are going to be more focused on probability sampling, because this has got a method, and non-probability is not as methodical. So just have to be careful with understanding probabilities, because this is what's going to come in the exam. Non-probability sampling is not considered as important for CI for the exams, I guess. Now, probability sampling is simple. These are the different types, or this is how we have named them. Probability sampling techniques and non-probability has all these different types, which is all given to you as headings in bullet points. So let's look at the one on the left. This is probability sampling: simple random sampling, stratified sampling, systematic sampling, cluster sampling. And by the way, just so you know, these are just some of them, and there could be few others techniques that are not mentioned here, because they are subsets of, or they are ancillary to, or they are subheadings to these main headings. Like in simple random sampling, there could be few more ways in which you can run these methods. Stratified, again, you can do it in different ways. Most of the sampling techniques that we will deal with will give you enough idea to get a sense of what other type of samplings you may require, or you can be very creative about plucking those or bringing those sample sizes. It's just that the conceptual understanding is important at this point. So I'm going to start with simple random. In after the 10 minutes, I'll take 10 minutes right now. I have to get a cup of coffee, and perhaps you should too. I'm just going to try to finish as much as I can, because of the shortage of time we have with next three classes that's coming next week, and I have to finish up module 3 and internet law. So that's going to put us on a very tight spot. For that reason, I might have to stretch a little bit today time wise. So you're most welcome to stay back for another, I guess I'm assuming it could be 10-15 minutes over. Unless that is a problem, anybody can leave without any issues. I'll still keep my recording on, and if you want to catch on it later, you can do that. So I'm going to take 10 minutes right now. I'll see you in a little bit. Sorry about that. No, I was just saying that I checked in the box, and it seems that the one that has a folder named CRS Training Guide 5.0, it has the book that I just opened up, and it seems that it has about 400 what? I just checked and went
Yeah,
to the
no,
log.
you're right. I was looking in the wrong folder. I was
Okay.
looking at the WS Training Guide 1190.
Mm, Is there a folder named? Because I just want to make sure that we don't have anything irrelevant or something that might be confusing. I don't know if there is a folder. Okay, this
Yes,
one, class notes, class schedules, course syllabus, PowerPoints,
there, the
research
very
info,
last one.
WS training. Oh, that's just, we had one of the students who took a course. It's called Web Search Skills, and that covers module 2. So I guess this is meant for those students, but at the same time, you can also use it not as relevant for you, because anything that is included in WS book is covered in 5.0. This is, what you call the mother of all. It has everything in it that is taught in CIRS course. A part of it is actually extracted and placed in WS reference guide. So yeah, I mean, that could be confusing, but yeah. So that's just an additional piece of book. You
Okay.
shouldn't be worried about.
Okay.
Okay.
All good. Thank you.
All good to go. So we're going to continue with the type of what we call probability sampling. One of the methods is simple random sampling, which is more like a raffle that you get, like you put so many of the numbers in a bucket and just pull one. So that is simple random sampling. It's random because you cannot identify each of those numbers with the way they're placed inside of those, bucket of numbers that are to be selected from. So if it is 250 employees and you have to pull one as a sample, you could just simply randomly pull one. It's very simple, nothing to it really. That's simple random sampling. And then we will talk about stratified sampling. Stratified or a strata is really something that gives you the opportunity to make subsets of something. Could be numbers, or it could be name of people, could be anything. So let me give you an idea what strata means. I'm writing it down right here. So if it is, let's say, a population from which you have to make your selection, the second thing you would do is, in population, you will split it into stratas. Stratas are groups. So there could be different groups in a strata, and and there could be several stratas, and you could create more than one stratus. Okay. So while the stratus are, containers of number of groups, and on the other hand, you can also, from the population, just work with the groups if you like. Okay. Or the stratus may not have groups, but it may have from the population, the mm, different stratus can be randomized, and groups can be randomized also. Okay. But we need to get better understanding of why we build stratas and what it means. So for that reason, we will look at the chart, or could say it's easier to learn from the example here in your book on page 340. Now, expand it a little. It's just too jumpy. I don't know. Okay, let me just use this slide. So here is the example of building stratas. Stratas are groups. As you could see, we've made two stratas here. Starting with the population, supposing it's a population of 1,000 employees, 800 are females and 200 are male. You could right away see that the sample that you have taken from the population of 1,000, there is 800 females and 200 males. That means there is a ratio here. I think we've got, which means one times. So there is a ratio of 80-20%. Okay. 80% females, 20% male. Now, what you do when you create strata is that you separate female in one group, or they could be groups, or they could, depending if there is too many departments, maybe inside of the strata for females, you want to be more specific on the type of work they do, so you can split them into groups. But for now, just because we are talking about stratas, think of it as one strata of group of people that are female. So if you need to make a strata out of it, you would actually maintain a ratio, or they should have some rationale to why you would select, let's say, 80 females to create one strata, and on the other hand, you created another strata of 20 male employees. Right? So 20 is to 80. Okay, so there is a sort of a ratio maintained only because the entire population is split into 80% female and 20% male. So if 100 is the sample that you want to deal with, or the number of employees are to be 100, you have 80-20 ratio. And then with this ratio, you can justify that you have maintained a sort of given it an equal chance, or your sample is has a rationale of why it is representing 80% female and 20% male, only because that ratio is somewhat justified with how many, so that there is no bias involved here. You're maintaining the sample ratio. So you have created two status. Now, from these two status, you can randomize it by mixing these two selections and coming up with 100 employees. Eh? So basically, it is just combining two status to take out a sample of 100 employees. That's stratified sampling. There can also be a system that you can adopt in certain situations which deal with different status that you can build. For instance, in a more systematic stratification, you could see that there could be a sample of employees which is not separated as males or females, but rather based on some rationale of their specialization or there being certain departments, assuming it's not given in this example, but assuming the sample of employees is right here in this as being taken out from the population. And here is what it is giving you in terms of numbers. So all employees of the company are listed in alphabetical order. So when you are taking out the main sample without splitting it into further status, you have built a rationale of selecting those employees. And first of all, you have built a list. Let's say it could be alphabetical or it could be the employee numbers, but it is systematically built from, in some sort of hierarchical order of numbers, starting from A, if it is name, if anybody's first name starts from A, or it could be an employee as 100 employees to start with, and then 101, 102. So you're going to list them. And then you can apply something. I don't know, we haven't done the statistical method yet, but there is something called uh, um, um, uh, mode. Mode is where you're going to pick every sixth employee. So every time that you have a list that you're going to use to make your selection, you can do every second employee or every 10th employee or every sixth employee from that organized list. If it is not organized in a certain way, you won't be able to do sixth employee or every sixth or ninth employee, because the rationale will fail at that time. And therefore it has some order to it. So let's suppose we picked up every sixth employee, and every 10th employee is selected, or every sixth employee is selected. But whatever the selection might be, you would have to deal with one list that is alphabetically arranged. Okay. Or you can take a sample of 100 people. So you have taken a strata. uh, First strata that you have built is organized. That means it's not randomized just out of a list that is not got an order to it. So if there is an order to it, you take out the sixth or the 10th employee and put it in this in this strata. Okay. um, So this is every sixth employee. So the one that you're seeing in this orange round circle with the yellow colored individual, that would be the selection. That would be the person, or every sixth person that you have selected. And as you keep selecting every sixth persons, they come into a selection of 100 people that eventually would be your sample size. So every sixth person is placed in the final strata, or the strata in which you are going to do your testing, or the sample that you're going to work with. So this has got some sort of organization of how you have made the selection. This is called systematic sampling, or it is systematic stratified sampling. Then you've got another one which is called cluster sampling. Cluster sampling usually works well when you have, organization that is large enough with several offices or several departments that are spread geographically, spread across the country or anywhere in the world, except that the cluster would allow for you to encompass or put together or select those locations, and from individual locations you will select a certain type of the positions of individuals that would be part of your sample. So let's suppose in one location you have 23 employees from production department at managerial positions. In group 2 you've got 27 employees production department, but they are production workers, not managerial positions. And then in the third location you've got supervisors. So you do these under a cluster. You create a cluster which is representative of a data or a sample size, which has a rationale in terms of finding the group of people that have similarities or dissimilarities, except that you can go from one cluster to another, especially if it is a long-term research and you have to go geographically, from one region to another. So you can create several clusters. So this circle itself is one cluster, or one way of identifying or doing systematic research and collecting samples in cluster one. Then there could be a cluster two, a cluster three, and so it goes on. Sometimes you have to do it stage wise, where you, depending on the outcome of your sample size research, you find that you need to expand your research or add more clusters to it. You would do it based on the decision you take after getting the first cluster worked on, and that would give you a direction of whether it was about enough for you to have made it a compelling research outcome, and if not, then you would move to the next cluster. Okay. So it just expands and gets reduced. It can be within a location, it could be outside of the same location, could be different departments in the same location. So you have to strategize of what approach you're going to take, depending on the milestones, the timelines, the outcomes, the type of samples that would fulfill the objective of your research. So all those will come into play for you to make some sort of a decision on selection of sampling techniques. Here we have only discussed some of these to give you an idea that sampling is not only important, but it is required in long-term researches or research that involves, some sort of, you know, um, it needs, depends on whether your observation is based on techniques that is actually acknowledged and accepted, first of all, by your client. So if your client says that the sampling that you have selected is not good enough, or it is not homogeneous, or it is not going to yield the results, or your subjects or objects of research are not going to fulfill the requirements of the outcome of your research, then you won't be able to proceed. So you have to get an okay for the sample size and the sampling techniques. Then you've got multi-stage samplings, which means that now you have a huge population which is absolutely out of your domain or your resources to handle, and you have to create a rationale for bringing that population down to the one or to the number that you can comfortably work with or have more control over. Then you have to start from the main population and then create several different samples out of it to bring it down to the smallest sample. So it is stage wise going to bring it to a point where the rationale starting from a large resource would come down to a small source, yet it has a way of bringing it down to that level, uh, and has a rationale all the way through at every stage to make those selections. Like the population of US school children, it's huge. So first, what you do is you apply random sampling to select the state schools. And then, when you're doing your state school selection, you can do stratified sampling, you can do random, it just depends. But this could be the first stage. In the second stage, you want to narrow it down further. So you are going to select from all of these states, the ones that you feel could be a kind of selection with some rationale to have it randomized, but at the same time, in the selection of reducing the school districts and school sizes, you have the selection that is representative of what you would run as a sample to eventually come to the conclusion or to the observation solutions. So you got sampling states selected in second stage, and from these states, you're going to then further find another sampling technique to get to the schools in states selected. So let's suppose these are the states, and these diamond shaped ones, these are indicating that these are the schools selected from one of these states. So from all these many states, you selected 1, 2, 3, 4, 5 states, and from 5 states, you selected one for the schools that it has. And from those schools that you've selected, now you can actually run this in stage 5, which is where you can apply this sample. So it is going to go stage wise from stage 1 to stage 2 to stage 3 to stage 4 until you reduce it down to the main sample size you want to work on, except that it has to be small enough, yet it has to have some way of randomizing that is acknowledged and accepted as the method for working in at different stage levels. So you've got multi-stage sampling here. Okay, and then we have non-probability sampling techniques. Now, any question on the previous one? We got done with the random sampling. So random or probability sampling techniques, you can get a sense of what it usually, why it is, first of all, why we need sampling and why it has to be organized and why there has to be a method to the probability techniques that we apply. Probability simply means giving it equal chance, not to have bias or to have some structure to how it is obtained. So that is random, as well as random in not in the literal sense, but random to a certain extent, and then there has to be a method to it. So that's where we are going to end our probability sampling. One thing for the exam is that in the exam, you don't have to define what probability sampling techniques are. All they will give you is these charts, because in the exams, you don't have a lot of time and they know it. Your examiner just wants to know if you can identify with or connect with, let's say, the diagram that is shown, and it would say if this is identify it with the type of sampling, and they'll give you the multiple choices. You would know that this is multi-stage sampling. Okay, or they would say, is it a probability sampling or non-probability sampling? So, it is not as complex for you to actually um, come up with the randomization process. You don't want to do that. It's not going to ask you to do that. Then we've got, and by the way, I did give out the practice exams. Please, if you are interested in getting through the CIRS exam, um, try out those Q&As for practice. And I can almost guarantee you that if you get about 70, above 75% or 80% score in your practice, you would be able to pass those individual modules very easily. And the more you're going to delay it, or more you're going to not take the challenge and wait for the right time, it's going to become more difficult. Okay. So just find time to practice with those. And as soon as you get to the level of passing and percentage wise, um, just take your final exams. Final exams are also in your Dropbox. Don't worry about how many times you're going to fail. Just think of it as you've got a lot of chances. Like, it's not going to exhaust your attempts if you don't pass in 3 or 4 attempts for each module. You can always get more attempts. All you have to do is just send an email and they'll tell you where to get it. Thing is that it won't take you more than 2 attempts to pass each module. That's my assessment, and I know from my experience that that's how things are working for other students. Okay, so non-probability sampling, there are non-probability is not difficult. Convenience oriented, you could see in this chart, there is one person who has now we are talking about human subjects. We're not talking about anything that is non-human. Not talking about businesses and, and anything other than humans. So this is where we are taking our examples from, and mostly that's where we need a lot of sampling techniques. So convenience sampling is one method which is proactive. Now, supposing this person in gray color, this is the individual who wants to do the research. They obviously want to make it easy for themselves and look for subjects that are around there or closest to their jobs, or they know people already. So that's this convenience oriented. Okay. The one in green color is the person that perhaps recruited others, or this person identified others in the group. So the green is the one that is, one of those that might be your colleague or someone that's helping you to identify subjects that are easy to get to. So that is convenience sampling. Voluntary response is when you have people that are invited, formally invited, and you are giving them some sort of incentive, like you may just give them some gifts to participate, pay for their time, so that they would volunteer for it. There are instances where you actually need volunteers. You cannot go and ask someone just to participate, depending on the sensitivity and nature and acceptance of that data that's collected from these interviews with these individuals. So you may as well ask them to volunteer. And volunteering also means that there would be some documents they would sign, and therefore, depending on the subject that requires permission, you would want volunteers to come to you. Purposive means that there would be recruiters involved. So these two in green color could be the recruiters that would look for others, or others would tell someone about. Let me just check the purposive. I'm not 100% sure. I'm kind of losing the focus on what it meant. I have to look it up, if you don't mind. I want to be sure what I'm talking about. Hang in there. Purposive sample is non-purposive that is selected based on the characteristic of a population and the study objective. Actually, everything will depend on the characteristics of the subject. It's not like you can just have anyone from the street to participate unless it is a very non-serious subject. So, what Purposive is saying that for the purpose of the object, your objective is very clear, and therefore those people have to qualify for you to select them. So purposive sampling is also known as judgmental, selective, or subjective sampling. This type of sampling can be beneficial to reach targeted sample quickly, and sampling for proportionality is not the primary concern. So, so if you need 10 people, and you can still do with three because they fulfill your purpose or they have those characteristics, you can get them or, put them in the sample. Then we have got quota-based. Quota sampling is non-probability sampling, a sample method of gathering the data from a group. Now, you have to understand one concept is representative of a group. Representative of a group generally means that they have some characteristics which qualifies them or which is unique or which is similar to each other so that they fit into the sample and and it could be for different purposes. It could be for medical reasons, could be for social science experiments, it could be scientific, whatever the nature might be. This is quota based, where you are looking for this sample in terms of numbers or gathering group that have similar characteristics. But what is important is the last one, which is a typical question because of how it is named. They call it snowballing sampling. Snowballing sampling question usually comes in frequently because students sometimes get confused what snowballing would mean. So snowball sampling is through the recruiters or through known people who regularly gather the subjects for your sampling, and those people in turn gather more people, or they are connected with even more people in the same group. So if it is a clinical research, and taking example of clinical is easy, that has a certain type of characteristics of psychological issues, for instance, and they are part of the group, or they know people in the same group which they call support group, then perhaps they can go into that support group and recruit more people. And those people might again be connected, or one of those that are gathered or are invited by one of the participants might have know others as well in similar groups or through their support group somewhere else. They would also be able to get recruited. So it is like one person recruiting another recruiting another, so it is kind of a snowballing sampling effect, and we call it snowball sampling method. Therefore, the non-probabilistic methods are more proactively done by either recruiters or by researchers directly, except that they have given different names of how it is collected. So when you are writing your sampling reports, or you're getting your samples approved, or when you are delivering your research uh, or response to your or you're quoting your research work, um, you have to mention the sampling techniques. Remember, when we did our market research sample, it did not have the sampling techniques written in there, but there would come a time if the sample size is too big or it has a unique situation which requires sampling, you have to mention that in your report. And these sampling and recruiting is costly also. And for that reason, you have to build into your response for research with the exact budget and cost to recruiting these samples. Then we have hmm, should be able to finish it, hopefully. Data analysis. Now, data analysis, like the wording says, that you have to know that a data in itself uh, can be useful if it is used to perform relationship analysis. A single data unit is irrelevant usually. There has to be more than a few numbers or a few attributes that can be correlated. So correlationship is important, that they should have some sort of that it should be able to identify a certain pattern in relationship to other data tables. These can be historical, it could be projections, it could be existing collection of information. Whatever the time um, gap might be will also influence your analytics. You should also have the method intact or available for not only collecting them, but a method of how you intend to utilize certain type of data for analyzing, say, qualitative data versus quantitative data. Your primary and secondary sources would also be the influencer. Your volume of data or numbers, if they are obtained raw as unrelated data, would also have an impact. That means that you have to organize that into tables and then create relationships. And that's a lot of work also. The data also has to have some meaning for it mm, to be presented in a in different presentations. For instance, it could be data visualizations, it could be a data that requires a data dispersion method of analysis, which means again it has to come across not only as numbers but as charts or graphs that would show the dispersion of information as more concentrated at a certain timeline or at a certain coordinates of X and Y, whatever is on your X and Y. So I don't want to confuse you, but I want to give you a sense, and I'm sure most of you have some can relate to what I'm saying. It's just that it is beyond the scope of what we are talking about, but at the same time, it would relate to how we have introduced it and how we are writing it in the book, so that analysis or analytics can be understood better in terms of, you know, what I mentioned with the collection, interpretation, presentation of all those data tables. So analysis of data analysis need planning, and I've just given you a concise picture of what planning would entail. So example of data analysis plan, for example, uh, the research can be broad, it could be exploratory, it could be specific to a problem, or it would just simply be management for the purpose of management reporting. It could be a short research of facts, or it could be elaborate research for uh, analytics, or it could be a research to verify or identify certain facts. But in this data analysis plan, we are talking about broad research, which means it's going to be exploratory and maybe something new needs to be found. So if the subject is democracy, for instance, concepts that you will work with or the objective of your analysis plan would be to find people's perception of voting. In this case, you may want to try your quick polls, which could be something that will give you quick information, more participants, easy to gather, not a lot of sampling required. Voting behavior of individuals, this might entail some surveys, questions related to identified. So this is just giving you some of the ways in which you are going to shape or plan your analysis. It is not a plan in itself. is just a guideline. So questions related to the identified topic. So if it has to do with perception of voting, do you think democracy is a better form of government? Yes or no? Could be the polls. Voting behavior of individuals. Did you vote in the last presidential election? And this could be the first question, and this would could also be the last question you want to get to, and therefore you're going to create the leading question, or the kind of questions that would lead someone to come to the main question eventually. Types of analysis, frequency table, cross tab with gender. You don't have to learn frequency tables. You don't have to learn cross tab with genders. This is just telling you one of the analytics that would be more suitable. So develop an index, cross tab with age. And like I said, you don't have to do any planning. You will not be asked to do or create a data analysis plan. All you would be thinking about is whether certain data analytics would be involve statistical methods, that is for quantitative analysis, and for other analysis that is qualitative in nature. They'll give you some samples on the survey questions that would be a mix of qualitative or quantitative analysis. So you have to identify, given the type of questions or the type of data collection method, what is the nature of the data that you will end up collecting with, um, or it could be a mixed method. So that's where it's going to end. Now we are going to look at types of qualitative data analysis. There could be one that we call uh, analytic inductions, and it is quite important, or you could say that in qualitative analysis, this is pretty much considered to be the typical or standard method. It talks about examining something that is similar, or a phenomena that can be compared with, or it is this given situation that would only change in terms of environment or the test environment, but the idea will remain intact. For instance, it is the common analysis of qualitative based on the observer's impression. Experts, bystanders, or observations examine the data, interpret it via forming an impression, and report their finding in structured and sometimes quantitative form. So analytic induction is basically, like I said, the idea could be that you are looking at one event or observing, let's suppose if it is a social science related project, and it has to do with the attitude of a sh- uh, of a cashier, for instance, in a bank, um, with against the the different race of people, or or their behavior based on religious background. If somebody is wearing a scarf versus those that are good looking blondes, or so there could be all kinds of interactions, but as long as the idea is the same, but it is applied in the banking, and then uh, at a teller's in counter, or it is at a like burger shop somewhere, uh, play the idea would remain the same. A grounded theory is more to do with how you are going to change. You start with a basic question, or the idea of your research is already established, or it is broadly put in place as something that's given to you to do your research work. But it sort of evolves with time and with the situation, only that it is going to demand that you become embedded in that environment. If it is to do with cultural things, then you may want to become, to be to start to live with them, or to understand their culture better. But the eventuality of grounded theory is that with the time, the situation changes, the direction of your research changes, and it sort of takes you away from the main idea to a new idea that you're going to develop, because now you are learning more and more through a more intimate involvement with the culture or with that setup. So the grounded theory means that it is going to be a qualitative data that is collected over time and it is changing. Analytical induction, same idea, everything will remain the same, just that your observation would would play would play on the analytical induction theory. These are theories, by the way. These are not methods; they're theories. So, grounded theory is one, and analytic induction is another theory. And there are 9 theories altogether. But 9 theories you don't want to go through because some of them are not even relevant, and we are more concerned about what we do on online or with the internet, and therefore more focus is on, remember, the interviews, the focus, the virtual focus groups, all of those methods or online surveys. So anything we talk about um, in traditional research method, as long as they work in the virtual world, it has more significance and importance for CIRS, and the examiner looks at it from the same perspective also. um, these are the theories that you got introduced to: analytic inductions, grounded theory. Then the method of how you're going to collect your qualitative data, even though it can be collected through all those other means of data collection, which we discuss under qualitative data. But the method of writing or collecting that information is what is meant or discussed here as qualitative data. It is not analytics, it is just a collection of data that you're going to be able to analyze or do your analysis later. The first method is called coding. Coding is when you are looking at certain information lines or certain main core words in writing the observations, which gives a broad, which is more concisely written but has a broad idea behind it. So if my coding is, let's say, um, I'm writing about mm, mm, Eastern European culture, and my more emphasis is on the gender or gender equality. Then within gender equality, there could be wordings that I would use as coding, something like religious bias or like male machoism. These are coded words that I'm going to use, more like the tags that gives an idea if it is something that needs not be written in detail, but through those coded words, we can generate a broader idea or connect with the idea for writing a detailed research report. Memoing, on the other hand, is freehand writing or something that you keep in your diary. These are more to do with observations, and clearly they keep changing. So as you do your memoing or you write something, there are some examples and methods both in coding and in memoing, which means that certain attributes like your date, time of collection of information, location, what was the objective of what happened during the day, what happened during the afternoon, how the subject moved from one place to another. Things like that would be memoing or writing it down in a certain structured way. And memoing is just ideas. That means it doesn't have to be concrete information. It could also involve your own notes or your own thoughts along with the style in which you're going to do your memoing for research reasons. Okay. Otherwise, it won't be acceptable. You have to submit a memoing diary or something that is needs to be arranged in a way that can be accepted as one of the supporting documents for your qualitative research. Same way, coding has the same value or the same consideration. In integrative, Diagrams and sessions means that you're going to have to sit and build all sorts of diagrams, cause and effect diagrams. Um, you can build any of the graphic graphs of your thoughts as what you call neural charts, or it could be brainstorming charts. So those are all integrative diagrams that you can use before or during planning your research work, or while you're doing your research work, or even after you have done your research work, to especially in causes and effect diagrams. So it has those different stages at which you can make it more visibly attractive and more easy for the research to be organized and presented properly. Then we've got analyze quantitative data. In quantitative data, we'll talk about statistical methods. That's all we will talk about. So as far as quantitative analysis, just because we know you or most of our students have gone through or read, at least in the school days, the main ideas behind statistical methods like mean, mode, median, standard deviations. Those are the concepts which you can relate to or more commonly understood. So we only brought this one into the CIRS. So nothing more to it except that. And by the way, when I explain this part, I don't want you to think of it as um, something that you have to compute, or in the exams they're going to ask you to do those calculations to find out mean of some numbers or mode or median. None of that is going to happen. All you have to do is to just get familiarized with the um, the terminology, and just identify these charts against what it means or what it represents. That's as much as you would get in this topic of statistical methods in quantitative data. So starting with mean, it's so easy. You could see that you add all the numbers and you want to find the average or the mean of it. Mean is the same as average. You're going to add all the numbers and divide it with the number of these numbers. So if there are six numbers, you add these, divide by six, you get the average, which is five. This is mean. Mode or median is the middle number. Or remember, when we did sampling, we did like every sixth person, but there has to be an organization of the data or the numbers. So let's suppose these are the random numbers, or these numbers can be, say, employee numbers, assuming 65, 55. There's no order to it. There is no sequence of numbers that starts from the biggest to and ends with the smallest. None of that. But to get a median, you're going to arrange it from the smallest number to the largest one from the list. And let's say you select every three, four, five, every sixth number. So the sixth is 56 here. And so it would continue where 56 would become a median number or the middle number um, in this case. Then mode is where the two numbers cross each other, or that could be the point or the delta of two variables coming up as equals, or it could be the highest or it could be the lowest numbers. So that is mean, that is mode. If you get charts like these, you would not have to worry about left skew or right skew. They will say, okay, uh, the one that is at the very top, or this point, is representative of the um, what is it, the mode is the top point, this one. So they would say, where is the mode would be the point where two lines cross and where everything cross each other to become equal. So mean, mode, and median at the top, and touching this would become mode. Measurability or so just identify this one and read what it means. The mode is the most frequent score in our data set. The mode represents the highest bar in the bar chart. That's all you have to know. Okay. The median is the middle score for the set of data. That's all you have to know. And you have the example. Okay. So no question would involve for you to compete to calculate mean, mode, or median. Then we've got measure of variability. Variability is to talk about where there is more concentration of numbers on x-axis versus y-axis. Just to get a picture, or just, when you look at a chart and the chart is presented somewhat like you're seeing right now over here, you would know what it is about or what it means. Or if you are supposed to design one of these charts, you should know if the variability or deviation has to be calculated. So what is variability and deviation? Measure of average, such as the median and mean represents the typical value for a data set. Within the data set, the actual values usually differ from one another or from one average value itself. Now, if it is confusing for you, you can look at this chart, and it is more, given details with the explanations that talks about chart 24.7. It is saying the number of different size tutorial groups in semester 1 and semester 2. In both semesters, the mean and median tutorial group size is 5 students. However, the group in semester 2 show more dispersion or variability. Dispersion means that let's suppose in one semester, which is semester 1, I want to compare semester 1 with semester 2. For what reason? To see the dispersion. Now, what the dispersion means is that in the first semester, you could see that the number of groups that got enrolled for that semester is starting from 1, 2, 3, and goes all the way to 8. That's on x axis. On the y-axis, this is the size of the tutorial groups, meaning that how many of the students made it or were part of that group. So 3, 4, 5, 6, and 7 are the groups. And these are the number of groups. So in semester 1, you could see that there was no students enrolled. Over here, there is a gap. In the uh, uh, moving further, you could see that there is a tutorial group 4 in which 3 students enrolled, or sorry, 3 groups enrolled in the 4th group. In the 5th one, you got 6 groups enrolled, and it is all visually available to you. When you put it in the chart, you could see that it is coming out like this, or this is the visual of how you would be able to find out against the next chart of what the dispersion is. Dispersion is the spread of, or the average, or anything that is going to give us an indication of one semester versus the other one, or one event or one situation versus the other one, that shows the spread of, or the enrollment of, the groups of students in different uh, in different tutorial groups with the number of students. So in first semester, nobody was enrolled in the third tutorial group. No student was enrolled, so there was a gap. In the second semester, you did find one group of students enrolled. Okay. In the fourth tutorial group, the number of students enrolled in different groups were 3. And so you could see that there was a spread, or there was visually available information that says that between semester 1 and 2, the the bar in the middle says that a lot more got enrolled in semester 1. In semester 2, less people or less number of students got enrolled in the same period of time. So you are just getting a visual of how one would see. If it is numbers, sometimes it's not easy, or it might not have about enough because this is a simple graph and there are 3D graphs and there are other ways of presenting the same information. There could be dispersion analysis, as I also mentioned to you, where there could be, different dots that you can create. And if those dots are in higher concentration at certain point between X and Y axis, you would know that this is, visually you could see, okay, this is where most of the action happened, or some of the events accumulated and were more successful, or whatever the criteria might be. It is visually available to you when you create these graphs. Dispersion is the spread from the 0 point, or the point which is the zero axis between X and Y, which is this point. Anything that spreads vertically versus horizontally will give you a deviation from the standard zero. And then there could be another type of deviation, which is what we call the range or the standard deviation right here. Standard deviation means that you're going to create a mean value or the average value or a standard, which you would use as a measurement against anything that is deviating from it. On the left of it, as it's shown right here, in the negative sense, it is decreasing. And after a delta or a period of what is considered as a standard mean, which is where I'm pointing to right now, there is a there is a there is a deviation of 68%, 50, 95%, 99%. The one that is moving on the left can be minus, the one moving on the right can be plus. But more importantly, the percentage is calculated between what is mean and what is deviated as these bars against the mean, or the distance of or the value of what is now converted into percentages, which can also be any other numbers. Right now, we're just using percentages. So deviation of this bar on the positive or the plus side is 68.27%. On the on the left hand side, it is again 68.2. So there is a uniformity or some sort of valuation or some sort of observation that would give you an idea of whatever you put on X or Y. It is not describing it as as something that we can name right now, but now what is uh, to be to be remembered here is the concepts of deviation. So deviation simply is the standard, which is the middle bar, and anything that is deviating from the standard, where the mean or the standard is considered 0%, and anything that is deviating is termed as the increase in value or decrease in value in terms of percentages against that zero value. So this is a standard deviation. These are one of the ways in which the quantitative analysis uses statistics or statistical methods. And some of the statistical methods we just discussed. So anyway, all that, and if it is frightening you, again, that is, I do get questions from students. They say that they don't want to sit in a class where they're learning statistics, or they don't feel that it is connected with their research, or how it is part of our CIRS, on to how far it's going to create complications in the exam. So I'll answer that very quickly for you. And first of all, it is important as a sampling technique, because remember, in sampling, you do deal with ratios, you do deal with ways in which you are going to obtain the samples. So to give it a rationale, even like sampling is one thing that it is used in. Other could be where you have to derive inferences, or where you have to build charts and present it to your client. Because I don't know if you noticed in the research response to research proposal, that document we had specified certain methods of analytics, or how we're going to do analysis of certain type of information. So given that, and given the fact that you as a researcher are supposed to know, or at least have a handle on how you're going to make a reasonable or uh, do or apply a reasonable method to give or to justify on how you've obtained certain results, you will be put into the situation that requires your understanding of these kind of methods. And last but not the least is that you will be dealing with certain data visualization or data analytics softwares. Nobody is doing it, like by creating those graphs physically by writing it, or building those research outcomes as they used to before. And now everything is going to be generated by the computer or that software. So once you get to learn about those softwares and start using those softwares, you would see that it would expect you to have some knowledge about these methods of analysis, both for qualitative and quantitative. It would ask you to separate data into certain, or they would ask you the method of how you're going to use your qualitative data, or how you intend to convert it, or what rationale or logic you want it to use, and it'll give you a drop down asking you to select one of them. And if you don't know those methods, then you have to go back and go into their learning software, um, notes, and again we'll come back to the same thing. So if you know of these things, it'll be so much easier for you to use those softwares. um, Univariate, bivariate analysis, bivariate more than um, two numbers or two variables. Univariate, just one number univariate you use for standard deviation. So you can give it a univariate, and then you would give them other variables. So not as important, but just to make sure that we have covered um, enough that would cover, or at least have the exam questions covered. We did that already. Now we'll talk about surveys and polls. And in this topic, I would ask you to do, and I have written it in the chat box. Previous message, I'm sure you got that. I sent it to everybody. Um, there was a page number I mentioned in the chat, page 277. No, what is this? Sorry. This, I gave you this one. Now I'm going to give you another reference to for you to check on this page and to think of it as something typically coming in the exam. So please read page 358 for differentiating between survey and polls. Okay. This is just a very easy to look at chart. It's not a lot of you can just read it in few minutes. So please keep this as a note, because I won't be able to go through it. Now, two type of questions that we will have to deal with in this one. We have the surveys mentioned. So there is surveys and polls. Polls is, there's not much about polls to talk about. That's just the differentiating chart that you have to learn. In surveys, there are two type of questions. Mainly, one is okay. One is close-ended questions. The other one is open-ended questions. So what you have to do is know these terminologies to understand the pattern or the layout of how it connects with the naming of these type of close-ended questions. And open-ended question, there is no there isn't any sort of criteria or different um, definitions of it. It's only one thing. Open-ended means that it's descriptive, freehand. You can just reply as you want. There is no structure to it. It's just a simple question, and it's something that you have to write as a note or respond to it freehand and with the free mind. In close-ended questions, there is close-ended means that it is given to you as a choice and it is crafted carefully, and there is a design to it and a method to how certain questions have to be distinguished or presented as either dichotomous, Likert scale, semantic differential, rating, ranking, and all that. In the exams, what will happen is that you would get a sample of questions. You would see how the pattern is laid out or how it is, present, how it is staged. That's the right word. And then it will be a choice for you to connect it with or cross-reference it to the type or the what this type of question is named. So it could be dichotomous, Likert scale. That could be easily answered if you can just recognize or have some way of remembering the layout of those questions. So that's what I'm going to focus on. So there is on the survey types, one we call longitudinal, and then there is a cross-sectional survey. So assuming that both of these type of surveys can be done on the web, some of the ways in which the internet can be used is obviously through web, online, there could be surveys that you can put online. That's what it means. It could be virtual focus group, social experiments, virtual interviews. Then there is ethnography, which means it's part of the social sciences or social experiment, but ethnography is when you start with the it is embedded. This ethnography is embedded in the grounded theory. So grounded theory is what is supporting the ethnographic approach. Ethnographic is exactly similar to grounded theory, except that it goes slightly deeper for someone to understand the subject matter or events or the social system or anything that requires a long-term research by living and sharing with the group or with the participants to you know and then you keep changing the line of your research based on how the environment on the ground changes. And there are social experiment clinical trials. So all of these are kind of web based. Also you can do it web based or non web based. I don't know why they put the word web here, but basically both longitudinal and cross sectional will work on these group of survey types. I would start with the easier part, which is the close ended questions, to give you an idea how they look. um, Close ended questions obviously are given with the number of outcomes that are kind of demarcations or kind of the answers that you have to choose from. So they're not open-ended. Therefore, they have a way of how you're going to design them or write them. Again, like I said, it is an art to create surveys or survey questions, have a reason for the way they are set. A dichotomous questions, for instance, would mean that it would have two variables or it has two choices only, either yes or no, good or bad. So one could be yes, two could be no. It's dichotomous. I don't know why they have to make it, give it a name, um, just for making it look complicated, but it is not. So dichotomous is two options, yes or no. Multiple choice is another set of close-ended questions. We are all familiar with it. Yeah. So you could see how this is designed. So in the exam, if a question comes that says that, this is the question uh, that has a pattern to it, and we'd like you to point out if what type it is. So you could just simply put it as a multiple choice question. Yes, Michelle. There are so many different softwares. SurveyMonkey is one, but when we remember when I was talking about the analytics or the software for for analyzing, those are very complex softwares, and you can get a free subscription to them to a certain level, or I think they do give you some period of time to actually play with it. I would also suggest, if you're doing SurveyMonkey, to and SurveyMonkey is got a way of how you are going to construct your survey questionnaires. But I find that for the type of recruitment that we do for, let's say, research firms, or based on our hands-on practice of how we conduct our surveys, we end up making customized survey questionnaires, which is the structure of how you're going to phrase them, or how you are going to collect you know
Yes,
productive.
that's what I do, but I do that at SurveyMonkey. I've probably used it for 15 years. And
Yes.
when I was a librarian, I was like the only librarian that did surveys on a regular basis. But I found that it was very easy to use, and that's how I learned like the different categories, because
Right.
you have all that to choose from. But I've designed some pretty complex ones, but
Yes.
I'm doing data analysis now in classes, and we're learning how to use different ones too.
Right. So you know that this is just for students to get familiar with, or get a direction and get a sense of why it's important for them to learn. There's so much more you can learn, especially in data analytics. That is a field which is growing tremendously. So much is happening in that area. Data science is most favorite subject for people right now because of the demand, I guess, and a lot of courses out there. SurveyMonkey usually is a kind of online, easy to use tool to put something, quickly online for it to be available for the users to use for the subjects to actually participate quickly. I feel that the survey questions that we are talking about right now, these are mm, not not meant for you to learn on how to create them. They All you have to do is to get make a picture in your mind of how the layout is like, only for the exams, because now I'm just getting more concerned about you coming very close to the exams and practice and all that. So my objective in this area, especially with the traditional research method, is for to make sure that you are able to answer the question. Most of the students find these parts to be more difficult, and they make a lot of mistakes in this. So I just want you to also know that don't have to do a lot more or read more than what is required, because the course is lengthy enough. So to get a shortcut or get an understanding of what typically comes in the exam should be your priority one. You can always use the book to learn more or to read more later on, but it'll be best if I get you through the exam, and therefore just get a visual of these, understand, like for instance, what is rating questions? How often do you purchase lunch? One, very frequently, and then the fourth one is seldom. So when this question comes, you know that this is a rating question because of the pattern, see the way it is written. So just visualize, capture, take a picture in your mind. All right. Then you've got Likert scale. So what is Likert scale? Sounds complicated, but it is very simple to identify in the exam if you know the pattern. Likert scale means disagree, agree, or somewhat agree. See what happens in certain type of surveys, the people are not willing to answer the question exactly, and they want you to leave a margin for them to, instead of not being decisive about it or leaving out the question, they might just choose something which is on the neutral side. So you're going to create a Likert scale for them. Here you've got somewhat agree, right? So you want to, even though it wouldn't it's easier for a lot of people who want to stay neutral or don't want to answer it, but at the same time it is giving you as someone taking the giving the survey, or I'm sorry, who's designed the survey, to get some sense of whether certain issues are sensitive enough or people don't want to participate or they don't agree with both things. So how many of those are there? That could be another statistic that you can gather. Otherwise, you won't get any answer or any real answer, or you'll get incorrect answer if someone is forced to either agree or disagree on an issue that is sensitive enough that they may have a totally different opinion. They might not want to use disagree or agree, and yet if they're forced to mark any of these two where the middle one is absent, they will be giving you incorrect answers. And so it continues. Then you've got semantic differential method, where there is a scale of 1 to 7, for instance. And so these are the patterns. So what is differential scale? Where you are giving a range of numbers between one extreme to another extreme, and you could put different versions or different ways of writing it. So these are ranking questions, checklist type questions, fill in the blanks, open-ended questions. I told you everything else. Now, cross-sectional. If I can cover cross-sectional, longitudinal, we'll be done. Um, um, Okay, cross-sectional is the type of surveys that basically one can answer on account of a subject matter that does not move or does not evolve, or one situation does not change to another situation from one period to another. So it is more, is less dynamic. It is the issue that is can be answered like right away. And there could be other surveys which move or are to be compared from one period to another. It could be because of the trends, because of seasonal changes, because of attitude changes, because of political environment changes, but it moves or it needs to be compared from one period to another. And therefore it is called longitudinal surveys. So cross-sectional is what we use mostly. Longitudinal changes with time because that's the nature of it, and that is what needs to be compared. Sentiments from one period to another, Um, so those are longitudinal. Now, samples we have done, everything else is not as relevant. What is online clinical trials? It would it would be easy to find out because it has something to do with medical sciences. It would mean that you will assign a human subject. Human subject has to have a certain type of situation, could be a health situation, a similarity between cases, or even dissimilarities. So those are online clinical trials, web-based experiments, or social experiments. Anything that you could see on the YouTube, mostly it's available. Attitude, that has to do with attitude, behavior, compassion, empathy, and those kind of subjects that are, environment related and so on. So that is web-based experiments. And you don't have to worry about anything else in the area of traditional research methods. We've covered everything that would come in the exam, and you could actually, the litmus test for that, or for your test, to see if everything not only got covered, but you have an understanding of at the concept level. You should start trying your Q&As, which is already there. And over the weekend, you can test them out so that the next week, which is our last 3 classes that I have to deliver, there could be enough time for me to answer your questions. Also understand the fact that, everybody's going on holidays. So some, and include, even I am taking like 5 weeks off. So, that's a long period of time. I never took this lengthy of a holiday. And this time I intend to do that. So that would make me disappear. And therefore, the next week is important for me to answer any of your concerns and your questions. I will be available on the email, and I do respond to my students. It's never like I'd leave you hanging, unless I see that you have passed the exams. My objective or my duty is to make sure that I'm available to you, for guiding you through or getting you through the CIRS. So I hope I'll get to see you next week. I know it's coming very close to holidays, but if you can come, that's fine. And there could be an option, which I think I've already discussed in the previous class, that since we have added 2 additional classes on Wednesday and Fridays, there could be a possibility, or there could be, that I might be able to give you a lecture on the same topics from the previous class, which can be somewhat similar, especially in these subjects that are to follow, as a business of research and internet law. So that could always be an option, but we can discuss that on Monday when we meet. The meantime, have a great weekend and enjoy your 2 days. I hope to see you all on Monday. Any questions so far? Or we are done, you think?
No questions. Thank you very much and have a good weekend.
Thank you, everyone.
Thank you.
Please
Thank
take care.
you.
Thanks.
Bye-bye. Take
Bye.
care. Bye-bye.